Problem F15-1. 0.5 kilogram ball strikes the rough ground and rebounds with the velocity shown. Determine the magnitude of the impulse the ground exerts on the ball. Assume the ball does not slip when it strikes the ground. Neglect the size of the ball and the impulse produced by the weight of the ball. So we'll start out with the equation mv1 plus the integral of f dt equals mv2. This is the impulse. So rearranging, the impulse equals mv2 minus v1. Now impulse moment, the impulse is a vector, so we could call these vectors, and so we can do vectors in coordinates, or in, so I in the x, or components, that's the word I'm looking for. So I in the x and I in the y, and so the moment, or the mass, is 0.5, and v2, breaking this down, the velocity down into components, we get 8.6 in the x and 5 in the y, and we get 17.7 in the y and 17.7 in the x, just using trig functions with this 30 degrees and 45. So in the x direction, we have 8.6 minus 17.7, and that equals negative 4.55. The impulse was that direction because it slowed it down. And then 0.5, and then 5 minus negative 17.7. Double negatives gives us 11.35, and this is Newton seconds. And so the magnitude of I is the square root of 4.55 squared plus 11.35 squared, which equals 12.2 Newton seconds.